I'll sketch a little version of it. Mine will be terrible because I am not a very good drawer. Okay. There's my lovely drawing. Okay, at an amusement park, the Ferris wheel has a diameter of 42 feet, and it's positioned 5 feet above the ground. The ride costs 7 tickets, so Charlie's going to time the ride to make sure that he's getting his money's worth. Once all of the passengers are loaded, the ride begins. Now that's an important thing to make note of. Once all of the passengers are loaded, the ride begins. We'll come back to that in just a minute. And Charlie starts his stopwatch when the ride begins. He reaches the top 9 seconds later and returns to the top when the stopwatch reads 33 seconds and again at 57 seconds. While on the Ferris wheel, Charlie's height above the ground, h in feet, is a sinusoidal function of time, t in seconds. Use the information in the description above and sketch the graph of this function on a time interval of 0 to 100. So by giving us this graph, the time interval, remember when they say the word interval, that's an x value. We're going from 0 to 100. So we're scaling by tens, and you can scale by tens on both the x and the y axis. Okay, now, let's plot the information that we've been given and see if we can figure out any other information. So what's a piece of information that I could go ahead and put on my graph? Anybody got any thoughts about what I could do? Time it takes to get to the top. I know this. It gave me 3 tops, right? I'm at the top at 9 seconds. I'm at the top at 33 seconds. I'm at the top at 57 seconds. Now, I could plot that if I knew where the top was. Where's the top? 47. Good. Because the top is the 5 plus the 42, right? So the top is 47. So I can go ahead and plot 947, and because of the way we're scaling, I'm actually going to put the ordered pair. So I'm going to put 947, and then I reach the top again at 3347. And then 5747. Well, from top to top, how many seconds is it from each top to top? 24. What do we call that? What value is that I just found? That's the period. In order to go from peak to peak, that's 24 seconds, and that's actually the question of B. The period is 24 seconds. Why? That's the time it takes. Now, because those are peaks to peaks, what has to be exactly between those? That's to be a valley, right? Now, I just have to figure out how low is the valley. And if you think about this for a minute, this is measuring the height that Charlie is above the ground. So this is Charlie at the top, he's at 47 feet. At the bottom, he's at 5. So exactly halfway between each of these dots, I should be at a height of 5. So halfway between 9 and 33, actually this one's real easy, between 33 and 57, exactly halfway between those would be 45. So I should have a dot at 45.5. And exactly 24 seconds before that, which will be at 21, I should have one at 21.5. Because just like the peaks, the valleys occur each period also. And since I have a peak and a valley, I can figure out where my D is, my central horizontal axis. It's going to be exactly halfway between. So if 5, I'm going to write it 4. If 5 is my lowest point and 47 is my highest point, then that's a difference of 42. Cut that in half, right? Or wait, is that right? Yeah. That's, my amplitude would be 21. So 21 below 47. Should be right at 26-ish. So right about here. And I'm going to go ahead and draw a curve here and see what it looks like. Not great because I'm terrible drawer. Alright, so it says to write a function. My A value I just figured out because I know that I go from 5 to 47. That's a difference of 42. Half of that is your amplitude, your A value, and it's 21. Now, if you think about this in terms of the actual problem situation, this makes perfect sense. 21 is the radius of your Ferris wheel. And if you think about it for just a minute, the center of your Ferris wheel never goes anywhere. It goes up 21 and down 21 and up 21. The center is the central horizontal axis. This is when you're at the top of the Ferris wheel. This is when you're even with the center. This is the bottom. So it's this up, center, bottom, center, up, center. It makes perfect sense if you think about it. So your amplitude is 21. My D value is 26. That's the 5 feet from the bottom plus the 21. Since it asked me for cosine, I just need in order to get my C value, I need to calculate B. But in order to get my C value, I just need my phase shift, and that's easy because they gave me the first peak is right here at 9. So my C value is going to be minus 9 when I plug it in. My B value I can calculate from the period. We said the period is 24. So period is 24, 2 pi over B. So your B value is pi over 12. And we got A, B, C, D. So we got it all. So my function is going to be h of t equals 21 cosine pi over 12 t minus 9 plus 26. Once you get a function, you can plug this in your calculator. So we're going to plug it in. Now when you plug it in, don't forget your calculator doesn't recognize t. You're going to have to use x. And also, make sure you're in radians. I'm going to set my window just like we just did. So from 0 to 100, scaled by tens. If you're not in radians, it's not going to come out right. like what I drew. Okay, question D. What was Charlie's height above the ground when the ride started? Now remember, they loaded the ride first. So if you think about how a Ferris wheel works, they let somebody on, then they roll it up just a little bit, let another person on, then they roll it up a little bit more, and we don't know which person Charlie was. If he was the last person to get on, he obviously would have started at 5 feet above the ground, because that would have been right when he got on. But he wasn't the first person to get on. We know that because his stopwatch would have started at 5:0, and it didn't. So we know that he's somewhere else. So I'm just going to Control T and put my table up and arrow back to 0. And he started his stopwatch when the ride started. So it was loaded, and when it started to go non-stop is when he started his stopwatch, and he was at a height of 11.151 feet, which means he was probably the next to last person to get on. It's like they let him on, rolled it up one more person, and then they started the ride. But he was at 11.151 feet. And then E says, the ride lasted 2 minutes and 5 seconds before it stopped to begin letting passengers off. At this point, Charlie drops the stopwatch over the edge of his seat. From what height did his stopwatch fall? At 2 minutes and 5 seconds. Now, just don't forget, your calculator, this particular function is in seconds. So 2 minutes, 5 seconds is 125 seconds, right? Because 2 minutes is 120 seconds. So because that would be a long way to scroll, I'm going to hit Menu, Table, Edit Table Settings, and I'm going to jump to 125. So he was at 36.5 feet. Okay, I am going to show you the picture for number 3. I don't think you need it, but I'm going to show it to you just in case you want to draw it in, because it didn't show also. Then the picture for number 4 shows, so you won't need it, but there's the picture for number 3. If you want to copy that down. Okay, the picture on the back shows fine. It looks just like it's supposed to. So real quick before I let you just go and do, on problem number 1, it's easy. It's a plug in your calculator. Just make sure you're reading correctly. The only thing is when you plug it in your calculator and you go to look at it, the window, you got to think very carefully about this window. I don't know if y'all know anything about engines. I don't, but there's a commercial. I've seen the commercial about oil and putting oil in your engine, and it shows like a thing almost just like this, and it shows it go. And when you crank your car, the pistons in the crankshaft, they go, I mean like so fast you can't even see them moving. So, and this is in time in seconds, but in a second, this thing is going to move a lot. So if your window is set, number one, to negative 10, 10, number one, you don't need any negatives, but in 10 seconds time, this crankshaft will probably go over 1,000 rotations. Which means when you graph it, all you're going to see is like, just lines like this. So actually, you need a window more like just 1 second. Do you understand what I'm saying? And maybe even less than that. I haven't done this one today, so I just told everybody, make sure that when you're thinking about this one, it is very, very fast. And so it's going to go multiple times inside of a second. So instead of going from 0 to 10, you may want to go 0 to 1, or even less than that, 0 to a half, something like that, in order to be able to see it in your window. I think the rest of it you can probably answer just by looking. When you get to the bottom of this one, first of all, I'll put this up and leave it up, because I think it's easier to see, because I have different colors, because it's in color. They want you to adjust this function and be exact. You can't just give me like oh yeah, it's shifted or whatever. I want you to find an exact values, and there is definitely more than one correct answer that would generate this picture. There are, I know of at least 3 answers that I've seen so far that generate this image with transformations. So when you get to this one, you look at that. And you don't have to start with number 1 if you don't want to. Like I said, it's a calculator question. The others, you actually have to plot graphs and stuff, so you might want to start with those. So go, and if you have a question, I'll be happy to help. If you think you have an answer and you want me to check your answer, I'll do that too.